I went through the force problem solutions in case you have any questions. So this is the first law of inertia for Newton's law. Object in motion stays in motion. Object in rest stays unless acted on by an unbalanced force. A lot of people get confused with the idea that an object in motion can stay in motion with no force. They think it takes a force to stay in motion. That is incorrect. We've seen that over and over again. Second law says an object's acceleration depends on the amount of unbalanced force and the amount of mass. So the more mass, the lower the acceleration would be, and the greater the imbalanced force or net force, the greater the acceleration. That relates to this formula here, which is also written like this, and could finally be written as mass equals force over acceleration. Number 2 is explaining Newton's 3 laws of motion as they apply to the following cases. So if the Voyager 2 spacecraft keeps moving at the same speed without using fuel, that's an object in motion stays in motion without any force. That's most like Newton's first law. The exhaust of a fighter, I meant to say fighter jet, I guess, goes behind the jet as the jet moves forward. That's the third law. That's interactive forces. So we have those equal forces in opposite directions. If you remember in class, we did demonstrations with two people pushing on each other with those force plates. This one, a truck with a mass of 2,000 kilograms, has an engine that applies 3,500 newtons of force to start it down the road. So that's looking at the amount of force and the amount of mass, so that relates most closely to Newton's second law of motion. Here, looking at problems 3 and 4, 3 was asking about the mass of an object that weighs 980 newtons on Earth. It was obvious to me that a lot of people try to Google this. That's not what I was asking you to do, because they got a weird answer showing no work. The goal is to rearrange this Newton's second law equation, which you should have down on your green formula sheet, and everybody should have a green formula sheet that equals basically force equals mass times acceleration. So rearrange mass equals force divided by acceleration. In the notes to your future forgetful self, I included the triangle to allow you to remember how to set these up. So we have this amount of force. Acceleration on Earth, you should know by now because we've seen it over and over, is 9.8 meters per second squared. So that comes out to about 1,786 kilograms. For part B of the problem, you already know the mass. Mass doesn't change anywhere in the universe, although force and gravity, the force of gravity can change. But on the moon, the force of gravity is less. The mass would be the same. So again, I'm using Newton's second law, rearranging it, and I get around 1.71 meters per second squared. Again, I saw a lot of people Googled it because their answer doesn't agree with what I'd had. Number 5, a bird flies into a window with a force of 15 newtons. Bird has a mass of 0.15 kilograms. I've always said, and this is really important, general formula first, plug in numbers, answers with units. So here, general formula, force over mass, answer circled with units. Here, general formula revised to solve for force. Force over acceleration equals mass. 750 newtons divided by the Earth's acceleration due to gravity, 76.5 kilograms. For this part, rearranging that, mass times the acceleration of the truck gives you the force of the truck on the person, or the force of the rocket on the person, pardon me. 7, again, Newton's second law, general formula first, force and mass, 2.25 meters per second squared. You're adding a bunch of people. I wanted to show you to show me somehow how you figured that out. 25 kilograms. And in order to get the acceleration now, it's the same force over more mass. So it should make sense. If we have the same force of the engine but more mass, the acceleration would decrease. It goes down from 2.25 to 1.78 meters per second squared. In this one, we've got an upward force of tension and a downward force of the Earth. I drew the free body diagram. Here I have 2 tension forces up because I've got 2 ropes and gravity acting down. So gravity is going to be mass times acceleration, so that's 49 newtons. Same here, 49 newtons, because it's the same amount of mass. But here, 1 string's pulling up, so the tension's 49 newtons. Here, 2 strings are pulling up, so the tension's half of that, 24.5 newtons. So again, hopefully that helps. Remember, we do have a test coming up on forces.